Hi ladies, in this video we're going to go through the difficult questions in 5C. I've put in some theory here. I haven't been putting theory in the other videos, but you should know that measurement heavily theory based in the sense that you've got formulas and you need to know how these formulas work. So in your textbook for 5C, first of all, you've got conversion of area units. So earlier you would have done conversion of just length, but you can see the main difference here is we square everything. So whereas before we would just multiply by 1,000, 100 or 10, this time we multiply by 1,000 squared, 100 squared, 10 squared, and that's if we wanted to go from kilometers, meters, centimeters, millimeters. But if we're going in the other direction, we're dividing. So dividing by 10 squared, 100 squared, and 1,000 squared. Now, just remember that area is measured in units squared. So when you're doing conversion, you got to remember that you need to square everything. And the same as if you were working with 3D shapes or the volume of a shape, you'll cube it. Okay, so just so you know, length is just normal. When you're working with area, you're squaring, and when you're working with volume, you're cubing. So it'll be times 1,000 cubed, etc. Okay, which is not what we're doing now, but we'll get there one day. Okay, then there's some formulas here. Okay, so it's not the formula for every single shape, but most of the ones that you will need are here. Oops, let me just turn my emails off. Okay, let's keep going. So I put them, the conversions are important because people always get mixed up with the conversions, but as long as you've got that theory there should be no issue. Okay, so you just look at, first of all, what you're converting from and what you need to convert to. So here we're going from kilometers squared to centimeters squared. So we go back to our little diagram. If we're going from kilometers squared to centimeters squared, we've got to go from kilometers squared to meters squared and then centimeters squared. So we're multiplying by 1,000 squared and then multiplying by 100 squared. So as you can imagine, it's going to be a very, very big number. But when you think about it, 1.5 kilometers in centimeters is quite big. Okay, so we've got, start off with 1.5. Now we're going, first of all, to meters, so we multiply it by 1,000 squared, and then we're going to centimeters, so we can do everything in one line. Okay, so 1,000 meters in a kilometer and 100 centimeters in a meter. That's where the 1,000 and the 100 come from. Now you can do that without the calculator, but I think there's so many zeros involved here that it's a good idea probably just to do it on your calculator. So I'm going to, whoops, can't see that I've just made an error on my calculator. All right, and just bear with me. All right, so sorry, I just paused so I could count how many zeros I actually had in my answer. So we've got the 1, the 5 with 9 zeros. And when you're writing your numbers, sometimes it's easier to group your zeros in 3 so you can easily see that. Okay, so a very big number. Sometimes your calculator will come up with something like this. Okay, so that's the same as 1.5 times 10 to the power of 10. But hopefully if you are getting this, you can change your settings on your calculator, but it depends on what calculator you're working with to actually know how to change the settings. But basically, this just means we're moving our decimal place 10 spots to the right, okay, which is the same as what we're doing here. All right, question B. Now I've got 0. On my eyesight, 0.00000. Is that 5 zeros? Okay, so 5 meters squared, and we've got to convert it into millimeters squared. So we go to our conversion table. Whoops. We're going from meters squared to millimeters. So we're multiplying it by 100 squared and then multiplying it by 10 squared. Okay, so this is why measurement's good to do on the calculator. Oh, that's a terrible decimal point. There it is. 1, 2, 3, 4, 5 zeros. Let's just double check. 1, 2, 3, 4, 5, 5. And then we want to go from meters squared to centimeters. So we're going to multiply it by 100 squared. And then we're going from centimeters to millimeters. So we're multiplying it by 10 squared. Now, with your 100, that's because there's 100 centimeters in a meter, and 10 is because there's 10 millimeters in a centimeter. So if you're wondering where those numbers have come from, that is where. Okay, so I'm just going to quickly do it in my calculator. 1, 2, 3, 4, 5 times 100 squared times 10 squared. Oh, and we get the number 5. Okay, let's go down here. So this time we're going from millimeters squared to meters squared. So we're going in the other direction now. So millimeters to centimeters to meters. And you can see we're dividing this time. So the font is a bit small, but it's divided by 10 squared, divided by 100 squared. Okay, so let's just get that back up. Okay, so dividing, first of all, by 10 squared, and then dividing by 100 squared. So I'm going to do that on my calculator again. Whoops, I accidentally pressed multiply. And divide by 100 squared. Beautiful. And my calculator leaves it as a fraction sometimes. So just making sure I get the right answer. So we've got 0.075. All right, moving on to question 12. So a pizza shop is considering increasing the diameter of its family pizza tray from 32 centimetres to 34 centimetres. Find the percentage increase in area correct to 2 decimal places. So we've got our original pizza, perfect circle as always. Its diameter, so remember the diameter is going from one end to the other, and that is 32. And we've got a bigger pizza with another awesome circle, 34. And that's assuming that your pizza is a circle, but it is referring to a circle. Okay, so basically it's increasing by 2 centimetres, but let's actually work out the area of each one, and then we can do the percentage increase. Sorry, I'm thinking as I'm going. So the area of a circle is pi r squared. So the radius of this pizza is 16. So I'm just going to substitute 16 into our equation. So pi times 16 squared. Let me just find pi on my calculator. Okay, and I get 804 point, and I'm going to do it to quite a few decimal places because that's what I'm used to. So 2477, that sounds good. All right, and the radius for this pizza is 17. So your area is going to be, and I've written the area formula here, so I'm not going to write it again. Pi times 17 squared. All right, just do that on my calculator. Pi times 17 squared. And we got 907.92. Oh, and it's 0.03 probably. Okay, so we want to know the percentage increase in area. So how much has it increased in area? So that would be the difference between the two. So 907.9203 take away 804.2477. Okay. And if you've already got those values on your calculator, you don't have to rewrite them. Just highlight them and press enter again. Okay, so that is 103.67. I'm just going to do it to 2 decimal places. All right, scroll up. So we want to know the percentage increase. All right, so the amount it's increased by is 103.67. And we put that over our original amount, which is 804.2477. And just to turn it into a percentage, we'll multiply that by 100. So I'll just quickly do that on my calculator, and you get 12.89%. And I'll just check the decimal places it wants it to. 2 decimal places. Okay, cool. I thought so. All right, so it's increased by 12.89%, which doesn't sound like much when you've only really been increasing the diameter by, sorry, it sounds like a lot, even though you've just increased it by 2 centimeters, but quite a big increase. All right, scrolling on to question 13. So a tennis court area is illuminated, so that means lit up by 4 corner lights. The illumination of the sector area close to each light is considered to be good, or the remaining area is considered to be lit satisfactorily. Well, that's a bit silly, because if you're playing tennis, this is the main area that you're actually playing tennis. All right, what percentage of the area is considered good, round to the nearest percent? Now, I added this question in because sometimes students have trouble actually visualizing shapes, but we've got 4 sectors here that form a whole circle. So when you think about it, if we were to put them all together, there's our 4 sectors, and they add up to a whole circle. So with our circle, we've got a diameter of 12 or radius of 6. So the area of this circle, so the formula is pi r squared. So it's going to be pi times 36. And I'm just going to do that on my calculator. Oh, why didn't you work? Okay, so it's 113.0973. And we want to know the area of the whole rectangle, so I might do that over here. So it's 30 and 12, and the units are the same, which is awesome. So the area of a rectangle is length times width. So 30 times 12 is that 360. I always doubt myself when I do things in my head. Okay, what percentage of the area is considered good? So we take the portion that is good. I might just scroll up here, otherwise I'm going to be writing in the middle. So 113.0973 divided by the whole thing, 360. And, well, I might multiply by 100 first, just because we're turning it into a percentage. Okay, so we've got 31, what are we doing, to the nearest percent. So I get 31.4 blah, 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 but to the nearest percent, it's going to be 31%. Okay, any more questions? All right, one more question, I think. All right, so we've got a sector here. It has a radius of 3 meters, so you can see that on the diagram. Find the angle theta correct to the nearest degree if its area is. Now, I might just see if we've got the formula for the area of a sector. Okay, so here it is. Theta on 360 times pi r squared. So remember the theta on 360 tells you the portion of the circle that you want, and then the pi r squared comes from the area of a circle. Okay, so let's scroll back down. All right, so 15a part I. So the area of a sector is theta over 360 times pi r squared. All right, and we'll just substitute in what we know. So the area of this one is 5. Theta is what we're working out, so you can just leave it as theta. 360 times pi, and the radius is 3, so 3 squared. Now, we are going to have to solve that. It's probably best just to leave your answer in, well, I'm just going to do, whoops, 3 squared, if you're wondering what I was doing, times 9, and then dealing with everything. So basically, let's get rid of this 9 pi first. So if I divide that side by 9 pi, so that means that pi cancels out with that, and the 9 cancels out with that. So I'll do the same to the left-hand side. So I'm left with 5 over 9 pi equals theta over 360. And then we'll get rid of this 360 by multiplying both sides by 360. Okay, so that disappears. And then you can just do 360. So theta equals 360 times 5 on 9 pi. So just be careful on your calculator that you do type it in correctly. I suggest putting brackets around this oops, actually not that. Let me just delete it for a sec. I just deleted a bit of the pi. Can I have you back? Okay, sorry. Put brackets around your denominator. But otherwise, your calculator might not put that pi on the denominator. So you've always got to be careful when you're dividing. Okay, so 9 pi. So 360 times 5 over 9 pi. And I get 200 over pi, but my calculator's just going to put it in decimals now. So 63.66. And what are we working in? Oops, no, sorry. It's not meters because we're working with an angle. It's degrees. And I wonder if it said to the nearest degree. Let's just scroll up and have a look. Yeah, to the nearest degree. So that becomes 64 degrees. Okay, the second part of the question, you have to do the same for 25. So basically, you're switching this area here for 25. So I'm not going to do that because the working out is much the same. Part B, explain why the area of the sector could not be 30 meters squared. Okay, so I am guessing it's because, well, let's just see what the area of a full circle would be if it was 3. So A equals pi times 9. Yeah, well, 3 squared is 9. So I've got that 3 here and I've just squared it already because when I write things, girls, I tend to actually think ahead. Sometimes I write things down incorrectly. So 28.27. So basically part B, why the area of the sector cannot be 300 meters squared, because if you had a full circle with a radius of 3, your area, which we just calculated, would be 28.27. So you can't have a sector that is greater than that. Okay, it has to be less than that because remember, it's a portion of the shape. A sector is a portion of the circle. So if your whole circle is only 28.27 meters squared, I didn't put that on, you can't have an area bigger than that. So you can have even 29, but you definitely can't have 30. All right, girls, bye.